Good day, welcome to Great White Retro. I'm Gord Fessick, and I've been sentenced to the basement. My topic today is this new workbench that I've got set up. I've got my Commodore 16 out here because I'm not only testing a new diagnostic harness that I've assembled, but I'm going to be testing a bunch of hardware that I acquired from Commodore shop in Hungary, because I'm going to be using that for a new project that I am starting in 2025. Let's get her done.
Here's a quick tour of the bench. I've got my power strip here. I have a laptop PC for looking stuff up, and I've got a screen for testing the devices that I work on here. Plus, it's a second monitor for the laptop. There's my soldering station. I have anti-static protection mounted here. This post here is a hole drilled into the table that I can mount my overhead light to, and that I can set things up on here. Just like that. I hope I can demonstrate the upcoming build a little clearer with this setup here. This always happens. You add some weight to an overhead thing and it's going to shift. Okay, so this is my Commodore 16. I put together a test harness. The test harness includes a port for the cassette port. It also draws 5 volts and ground from it. Rather than using the power and ground off of the joystick ports, I'm grabbing them off of the cassette port. And the reason for that is I want to be able to use the same test harness with standard Commodore / Atari joystick ports with the 9-pin connector here. I'll explain what's going on there in a bit. That buffer on there will work regardless of which joystick port's plugged into which port back there. This keyboard loopback is specific to the Commodore 16. To adapt it to the +4, I would need to get one of those ribbon cable things, but for my project coming up, I'm not going to need that. I've got a simple serial loopback. It just ties pins 4 and 5 together, and I have gone to the trouble of adding heat sinks to the main chips that get pretty toasty. This is the main processor, this is the TED chip, this is the PLA. This is actually the new quote-unquote PLA from Commodore shop, and this is my EEPROM with the diag264 and so forth on it. Here's the user port loopback for the diag264 test harness. There's no fancy electronics on here, it's just straight loopback. Obviously I can't use this on a 16, but I will need it for my special project. These are metallic mounts for a Commodore 64C. This mounts the keyboard to the case, because unlike the bread bin, the keyboard actually mounts to the top of the motherboard rather than to the underside of the top of the case. These are some of the ICs that I ordered, and we have here 2 8501s. Right, these are the main processor for the TED series machines. I have what looks like 2 8551. These are serial UARTs. These are used on the +4. 6581, that's a SID chip. Here's another SID chip. This is the 8360. This is the TED, or text display chip. That's the almost system on a chip for a Commodore 16 or +4. I have one CIA chip. This is actually meant for Commodore 64. These look like Commodore 16 keyboards, complete. Yep, that would appear to be the case. Both are somewhat yellowed, so they're going to need some retro bright. I believe these will fit. Now, wait a minute. How do I do this? I believe these will fit in a 64C case without much trouble. Look at that. but I've got my cassette tester and my serial port or IEC port tester plugged in. I have the shift lock key depressed, which means that Diag 264 should bypass the tests for the keyboard and the joystick ports. Let's see what we get on the screen here. Keyboard skip, joystick skip, cassette serial port OK. User port skip, RS-232 skip. Alright, let's see. Escape is good. 1, 2, 3, 4, 5, 6, 7. I do believe the keyboard is working. Okay. Yeah, everything is coming up green. And for the first time, okay, bottom, top. For the first time, let's try the user port adapter. Make sure we didn't short anything out. Okay, we're not shorting anything out. Okay, RAM, function ROM, keyboard skip, joystick skip, cassette okay, serial okay, RS-232 port bad. Oh dear. It seems to think the user port is okay. I'll have to see what 0101 means for the user port, unless this UART actually is bad, which it might be. I don't know. Well, I wasn't expecting to do any work on this bench today like this, but I'm also going to replace this hex inverter here. It's a MOS part, and I've got a pair of standard parts that I'm going to replace it with. Right, they were from my other project, but I'm going to use one of them now at least just to rule out that this is a problem. I don't want to rip out any traces, so let's try loosening these from the back here, from the top. Forward. I think that might have it. Oh yeah, there we go. There. That actually came out a lot better than previous attempts. I'll put a socket in here, and I will put a stock part in there. Let's give this a shot. We've got everything but the keyboard and joysticks hooked up. It's going to fail on those, but that's fine. Okay. Serial port. Here we go. There we are. Okay, serial RS-232 is okay. Well, I wasn't expecting a +4 repair video today. There we go, MOS logic again. I went and picked up a new pack of toys from JLC PCB. I didn't do PCB Way because they didn't have an option for just throwing a random Gerber file up without specifying the size, and I wasn't sure how to deal with that. These guys, however, had no problem with it, and they produced for me some boards. This probably does not look familiar to anyone because this is a fairly new product. This is the LittleSixteen by Sukopera, and of course by everybody else who designed the original Commodore Plus 4. The reason why I had to prepare a cassette loopback like this, and joystick connections like this, was because I am building a modern Commodore Plus 4 with all off-the-shelf parts. I've got 5 of these boards here Looks like PCBWay is sponsoring Sukopera's project. I gotta figure out how we're going to order these from PCBWay when the time comes, but let's get one of these open. Alright, let's take a closer look at this board. So everything from here to about here is the Commodore 16 side of this project. It takes a TED chip or FPGA equivalent. It takes one of either the 8501 or a Commodore 64 6510, but that will break compatibility with things like Jiffy DOS, so be careful there. It can take some original Commodore parts, or it can take modern equivalents of those parts. It has a lot more RAM than even the Plus 4 will have. It'll have some banked RAM. It'll let you switch between ROMs. The idea is you may be able to load all of the function ROMs, including the 3+1 software, onto a single EEPROM, saving on power and space. That may show up in a future revision of this board. The PLA has been replaced by 3 GALs, and these are available from Atmel and they're available from DigiKey, so you can do modern ones, and the currently available EEPROM programming software will program these parts. Past this is the Commodore Plus 4 side of things. There is one of those, there's a space for UARTs, there's the inverter that I was having so much trouble with earlier, there's 2 different kinds of parts that can do the parallel I/O part of it, and then there is the really esoteric stuff. There's space here for a SID chip. And I am looking forward to this part because I really want to try out some of the Plus 4 software that supports the SID cartridge, especially the stuff from Cytronics. I really want to see what's up with that. It's too bad that Pets Rescue doesn't support that, but I believe there are many other, well, okay, maybe not many, but there are quite a few titles that support this. So to be able to test this with the Diag 264, I need compatible interfaces. So I need the cassette port stuff. This is a standard Commodore dataset port. These are standard 9-pin joystick ports for Commodore and Atari style joysticks. So I'm going to have Commodore/Atari versions of this cable when the time comes. And this is not an RF output. This will be just regular audio video, so no RF. We'll see how well that looks too. All of this is meant to fit in a modern Commodore 64 case. And you bet I got the retro black versions. All of the modern parts are available from DigiKey, or there are modern equivalents of those parts. For the CPU and TED chip, you will have to use either original parts, or you will have to use FPGA equivalents of those. We'll see how that goes. So you'll need to use an original TED chip, an original 8501, or the adapter board that'll let you use a WDC 6502, and we will see how this project goes. And I've got a bit of a story. I ordered 5 of these. I intend on building 2. So thank you, Sukopera, for letting me play with release candidate 16 of the LittleSixteen.
This project wasn't cheap. I ordered enough components to build 2 systems, and that cost me just under $1,000 bucks. So that's about $500 per machine. And that doesn't include the labor and troubleshooting that I'm expected to do, or the preparation of testing tools like the diagnostic harness that I prepared. If it helps, it does seem like I'm paying around $160 bucks in 1994 dollars, so that makes the LittleSixteen version 4 cost competitive with the original Commodore 16, but with having better video quality, better sound, more memory, and hopefully a more modern construction that can last another 40 years. We can probably get that costs lower with a surface mount version. Hopefully a version 5 will be all surface mount or majority surface mount. It'll use a modern 6502 processor, an FPGA replacement for the TED chip, and then we can bring that cost even lower, even if I have to abandon the Made in USA label, just like Commodore did. So let's talk about the elephant in the room. I ordered all of these in January 2025, Bridget encouraged me to order these before March to try to avoid the worst of the upcoming tariffs. Now, I know what import taxes are, I know why they exist, but for hobbyist computing like this, they just don't work, and here's why. My January order from JLC PCB was just under $100 for 5 boards, and I'm only going to be using 2 of them. That included fast shipping. Fast forward to March, and the same order actually didn't cost any different, and in fact it could cost even less if I cheaped out on the shipping. Now, I still believe even with the duties it would be far less expensive than what American PCB manufacturers are asking for. DigiKey has a custom PCB service now, and they are asking anywhere from 5 times the cost of what I paid to JLC to over 20 times the cost for the same product made in the USA. I know why the prices are different. I know that there's different labor conditions, different safety regulations, different markets, different costs of living. I get all that. These are things beyond my control and things that even Atari and Commodore had to deal with back in the mid-1980s. It just wasn't cost competitive to do made in the USA anymore. But even with a 200% import tax, or a 300% import tax, or heck, even a 1000% import tax would still be less expensive to order from Shenzhen than it would be from one of DigiKey's suppliers here in the US. In fact, I was going to have custom labels done for these machines that would have assembled in USA on there as a point of pride. Well, that point of pride doesn't seem politically appropriate right about now, especially since I'm Canadian, and that opens up a whole new can of worms that I'm not going to get into here. Well, thanks for putting up with me here. If you want updates on this project as it progresses, please subscribe to the Great White Retro channel, and you can also get updates on upcoming shows, additional projects, restorations, and more. Until then, good day.